This is Facility Science Podcast number 5. I am Jason Doolittle, and today I'm talking about capital replacement planning. So to motivate this topic, every building, every piece of equipment or machinery, every mechanical or structural component, every surface, every door, floor covering, roof, every piece of furniture, every sidewalk, every electrical device or pipe or elevator, even every tree, everything that's associated with your facility will eventually need to be replaced or substantially refurbished or rebuilt, and it will be expensive. So we have a choice. We can wait until something fails and creates an emergency situation and then run around with our hair on fire when surprise, surprise, that expensive thing we've been relying on doesn't last forever. And this is the default plan used by many businesses. And obviously this can result in unplanned business downtime and unplanned expenditures and unplanned loans, financing, etc. And we have another option, which is that we can predict when these things will need to be replaced and make a plan to replace them ahead of time, so before they fail. This is called capital replacement planning. Sometimes it's called recapitalization or capital renewal. And in this context, capital is any durable property that has economic value to the business, all those things I mentioned before and others. And I should note that this isn't a maintenance plan. You should have that too. This is a plan for what to do after maintenance. So to make the plan, first we need to assess the facility and the associated systems. So in order to make the plan for how we're going to replace everything, we need to know what everything is. And so we need an inventory, and we need to know the current condition of each thing so that we know when it will need to be replaced. And if you have a CMMS, that's a computerized maintenance management system, and you use it, you might already have a pretty good inventory. Now, the process of analyzing the condition of your facility and its component systems is called a facility condition assessment. And this is a topic by itself, which I might cover later. And also, in addition to assessing the condition of your facility, this facility condition assessment can be used to create an inventory if you don't already have one. Now, a proper FCA, facility condition assessment, requires expertise in a wide array of building concepts and is typically performed by architects and engineers and skilled tradespeople for the various building subsystems. You can hire a consulting firm to do the FCA. An experienced firm will have access to all the relevant resources and knowledgeable professionals to do the proper assessment. And the consultant can also help you to prioritize maybe imminently needed repairs or replacements, and also recommend maintenance practices based on what they see going on in your facility to prolong the life of your existing equipment. And if you can't afford to hire a consultant to do a proper assessment, you might have expertise in-house or with your maintenance or repair contractors to do a partial or piecemeal assessment, and making sure to cover the most critical systems first. So once you have an inventory, you need to determine the useful life of each item. And so you'll need to know the general useful life of a new item of each type, and also, at least for your initial plan, the remaining useful life in the stuff that's already in use in your facility. And the useful life can be determined by consulting industry organizations or manufacturers. Obviously, take manufacturers' data with a grain of salt, or your own experience with the type of asset, your own experience or that of some trusted experts, and your consultant, your facility condition assessment consultant, can also provide some insight into this. And there's various criteria that contribute to when you consider an item to be past its useful life. And some of these are maybe the most obvious is wear and tear or breakdown. The thing physically can't perform its function anymore. Often technological advancement can make certain things obsolete. So in other words, no longer useful. And newer technology might be much more efficient or effective. And another thing that can make an item be considered past its useful life is end of manufacturer support. So that might increase cost and risks associated with the use of that item. And this is especially relevant for items with specialized parts or for things like software and computer systems that need regular updates. And that's especially relevant for IT security. You're no longer getting security updates that device might not be safe for you to use in your business anymore. So we can use the generic useful life values, so that the values we would get from your industry organization or your manufacturer, and this is usually given in years. We use these generic values as a starting point, and the actual use case will affect what we consider the actual useful life in our own situation. So some examples of this is that an item that is heavily used obviously will wear out faster. An item that's lightly used may last much longer. So consider a high quality, lightly used door in a favorable environment. That thing could last 100 years or more, while a heavily used door in harsh conditions might need replaced after only a few years. Also, environmental conditions will affect the useful life of an item. So, for example, a rooftop air handler will deteriorate much faster in a salt air environment, so somewhere near the ocean, than it would in a dry area away from the ocean. So that'll affect the useful life as well. Maintenance can affect useful life. Well-maintained assets will last longer than neglected assets. Quality is another one. So a high-quality item will last longer than a lower-quality item. Although life cycle cost should be determined to see how more frequent replacement with a lower cost item compares with less frequent at higher initial cost item. Maybe not obvious without actually analyzing the full life cycle cost of both items. And then another thing that can affect our useful life is the construction or installation methods used when we've actually set up that device. So once you have an inventory and you have determined what the useful life of each thing is, we can make a replacement schedule. So basically we want to come up with a replacement date for each item. Put it on a calendar. We can look forward 10 to 40 years, maybe even more, depending on the industry and the facility type. So obviously the things that are happening closer in the future, so a few years from now, 0 to 5 years, are going to be more certain. And, the longer into the future you're predicting your replacement dates, the less certain those dates will be. But it's still important to forecast those. And, the most expensive to replace components last a really long time. Some might last 30 to 40 years or more. And then you would incur a massive expense that you don't want to be a surprise. So it's still important to look ahead, even though there's some uncertainty, by looking so far into the future. So these are things like the roof, the parking lot, parking garages, and building structural components. Again, these are things that last 30 to 40 years or more, but are extremely expensive to replace. And so you still want to have those sort of on your radar way ahead of time. And then some items will need to be replaced immediately. So these are things that are a safety hazard or are an issue with legal code compliance or have imminent failure, and your condition assessment consultant or contractors can help you identify these things. All right, now we have an inventory, we have a replacement schedule. So the next thing we need to do is estimate the replacement costs. And replacement costs include obviously the purchase of the actual item or equipment, and then installation and commissioning of the new equipment. And then we also need to make sure we include removal and disposal of the old equipment. For some things that's trivial, but for other things that may be a substantial cost. And there are several ways to get cost estimates. We can ask contractors or suppliers for estimates and make sure they know that we're not looking for firm quotes here, just ballpark estimates for planning purposes. The FCA consultant firm might also be able to provide reliable estimates for many items based on their experience. There's also contractor estimating guides. These are tools and resources that contractors use to estimate the cost of work, and also past experience in your own organization. You've replaced various equipment in your own facility, in your own organization, so you can use that experience to estimate the cost of future replacements as well. And you also have to figure in other costs of replacement, so things like design and engineering work, relocation or accommodation of normal users of the area if a replacement project would affect the normal use, and then project management or other use of your staff to facilitate the replacement project. And when considering replacement cost, the quality of the replacement will affect the useful life. I mentioned this before. And you should consider that a higher quality item might cost more, but also last longer, while a lower quality item might cost less but need to be replaced more often. And like I mentioned before, life cycle cost analysis can help you decide which is better. And also keep in mind that you'll need inflation adjusted estimates for budgeting in future years, and you can ask your accountant how your business would handle something like that. All right, now we have enough information to make a budget using the replacement schedule and replacement cost estimates. And this budget can tell us basically how much we'll need to spend on capital replacement in each future year. And also note, when you're making your budget and even making your schedule, is if you want to smooth out the estimated budget, a lot of the useful life estimates that you'll make might be divisible by 5 or divisible by 2. And so you can sort of smooth out the estimated budget by moving some things to other years. So we can move something, say, to year 13 or year 17 or year 7. Or if the estimates of useful life are given as a range, we can sort of choose the convenient years and the ranges for planning purposes to assign, to smooth out our budget over the years. And to make the budget, there's a lot of tools you could use. You can do this reasonably well with a spreadsheet. There are also purpose-built budgeting applications, and this functionality, this capital replacement budget functionality, is built into many CMMS or facility management software packages. They can take your inventory and your installation dates and your useful life estimates and your replacement cost estimates and generate this type of budget just automatically for you. All right, now that you have a plan, a budget, we have to get this approved. So your presentation goes something like this. Here's my capital replacement budget forecast for the next 25 years. Here's how I arrived at this forecast, and here's why you should take this seriously. If your organization already does this kind of planning, good for you. If you're well prepared, your plan should get approved. If your organization has never done this before, you're basically telling them that you plan to spend a lot of money to replace stuff that still works. And they might not like this idea. So it's important to speak their language, which is risk management and predictable expenses and benchmarks and metrics, in order to sell your plan for capital replacement to them. So one thing you do is tell them about the consequences of not spending money. Here's a story. So an air conditioning unit for a small data center failed catastrophically after probably more than 15 years of service, and the thing had been limping along for several years already. And there were really, at this point, no good solutions available. So a new unit was ordered with a couple of months of lead time, because that's how these things are. They're not generally the more vital equipment isn't stuff that we can buy off the shelf. They have lead time. And so this particular company had to rent portable air conditioning for the intervening period, which ended up costing actually more than the replacement equipment, the rental of the portable air conditioning. So that's a good reason to replace something before it fails. It costs you twice as much if you wait till after it fails. All right, so some of the consequences of not spending money are this kind of surprised, unplanned downtime and surprise capital expenditures, so surprised large amounts of money that have to be spent. And you also have the extra cost of dealing with the emergency, like when the story with the air conditioning unit for the data center. A lot of this equipment has long lead times, and so you have to make temporary provisions to keep your business running while we're waiting for the new equipment. And these temporary provisions can cost money, sometimes a substantial amount of money. Sometimes this surprise end of life might happen right in the middle of your production, while your planned end of life can be scheduled at the most convenient possible time. And this has value to the business. And if you've been in the business for a while or been associated with a particular facility for a while, you can probably dig up some examples to really quantify this and give them actual numbers about, in the past, we did it this way, and here's how much it cost. If we had instead chosen to do it this other way, replace it ahead of time, even if we had placed it a year or two ahead of when it failed, here's how much money we would have spent, that sort of thing. Another cost of or consequence of not spending money is the impact to the image of the business, to the customers or to the community when surprise things fail in the facilities. And then you also have the impact to the morale of the employees on the perception of the employer. So they say things like, we have to work in this dump where everything is breaking down all the time, and the bosses don't care about that. So these are all consequences of not spending the money. Now, to look at it from the other direction, we can talk about some benefits of the capital replacement plan. And there's the fact that I sort of opened with, that this stuff is going to need replacement eventually. So let's do it on our own terms instead of being surprised and dealing with an emergency every time. right? Another benefit is that we can do a proper job spec and bidding process for each replacement instead of only initiating the replacement as a response to an emergency situation. So we might get a lower quality replacement that costs more than it could otherwise if we had had the time to do the proper shopping process and spec for the job to get really what we needed in the situation. And also replacing equipment at sort of the right time can maximize the economic life of the old equipment and also maximize the benefits of getting the new equipment. So old equipment has higher maintenance costs and lower efficiency. So the longer something's been in use, the more likely you're going to have to spend a lot of money maintaining it. So replacing bigger and more expensive components that may last longer, but they'll fail towards the end of the life of the old equipment. And new equipment hardly needs any maintenance in the early years at all. And this can be quantitatively demonstrated by comparing the life cycle cost analysis of new and old equipment and finding sort of the theoretical optimal year for replacement. So the year when you expect that the more expensive maintenance will start to kick in on the older equipment. And so if we overlap that with the new equipment, we can kind of determine, like I said, the optimal year for replacement. And you're not necessarily going to do this for every piece of equipment, but to make the case about why this is a good idea to sort of spend money to replace things before they've actually stopped working is something that will be beneficial economically to the business. Older equipment also might have harder to get parts and service, making that reactive maintenance more expensive. So, for example, if you have some older equipment that uses a CFC-based refrigerant, so R22, Freon, that sort of thing, it might still be working great. But if you have a refrigerant leak, which happens occasionally, it's going to be very expensive, where a refrigerant leak in a newer equipment will be just a minor inconvenience. So that's the kind of thing where just having that equipment running, the same failure in an older equipment and a newer equipment is going to have a substantially different cost associated with it. So in a lot of cases, like in the case where if you have a HVAC or AC or refrigeration equipment using CFC refrigerants, it might make sense to get that stuff out of there and replace it with newer equipment that uses newer refrigerants that are going to not have these super expensive surprises associated with them. Another benefit of your capital replacement plan that's especially useful to the managers of your business is that we can have a predictable facilities capital budget year after year instead of always having to make emergency expenditures. Okay, another tool we can use to sell our plan is benchmarks and metrics. So there's the old saying, you can't manage what you can't measure. And business managers like things that they can manage. So one prominent metric for facility management is called the Facility Condition Index, often FCI, that's Facility Condition Index, and that's the ratio of the current facility deficiencies, so that's the outstanding maintenance, repair, and replacement cost, to the current building replacement value. In other words, that's the amount of money required to bring the facility to functioning like new condition divided by the amount required to build the whole thing from scratch. So basically an FCI of 0 means the building is in perfect condition, while an FCI of 1 means it would cost the same to repair the facility as it would to replace the whole thing. So you might as well replace the whole thing. And this is used to compare the condition of facilities relative to one another. And your CMMS, if you have comprehensive data in it, might be able to calculate this number for you. And so this is from FMpedia, which is from the IFMA Knowledge Library. Some values of FCI are commonly interpreted as follows. You have from 0 to 5%, so 0 to 0.05, that's considered good condition. From 5 to 10%, that's considered fair condition. From 10 to 30%, that's considered poor condition. And greater than 30% is considered critical condition for a facility. So you can present your current facility condition index and get agreement that this is a reasonable metric to use, and then also agree on a target FCI for your facility. And then you can show improvement year to year. And this can be used to justify also spending on maintenance programs, not just on capital replacement programs. So if you have this number that you can say, hey, here's our condition, here's what we can do to improve that, or maybe here's what we can do to maintain it if we like where we are. And again, managers like to be able to have something that they can manage. And this is the kind of metric that is useful for that. Another metric is replacement spending as a percentage of replacement cost of entire building. And a common reference is that each year you should spend about 2% of building replacement cost on capital replacement. And this 2% number is somewhat arbitrary. You shouldn't expect that you'll really spend 2% every year. It's just that maybe over the lifetime of the facility, you might average 2%. Some years will be less and some much more. Also, the 2% might not actually be right for your facility and industry. Maybe it's 1.5%, or maybe it's 3 or 4%. And the number obviously will be higher to catch up if the building is older and the assets have been neglected. There's a good article about this, gives some things to think about. It's called Recapitalization and Capital Renewal. What's the number? And it's linked in the notes, facilityscience.com/podcast, and this is number 5. And so basically the point of this is that the spend percentage can be used as a benchmark, and it can be tracked and managed and averaged and adjusted from year to year based on the performance of the capital replacement program to basically give your business an idea of how good of a job you're doing and how good the plan is. All right, now you have the plan approved, hopefully. And so now we need to fund this thing. And the method of funding your capital replacement plan depends on the accounting and investment philosophy of your business or organization, and also potentially regulatory restrictions on allocation and investment and spending. So, for example, if you're a public sector or nonprofit, you'll have some regulations on how money can be spent and invested. And so one of the ways these things can be funded is by having what's called a sinking fund or a capital reserve fund to pay for the planned replacements. And using your budget forecast, you can calculate an annual or monthly dollar amount to add to the fund that will cover the replacement plan given the expected expenses for each year. And this allows a smooth, consistent allocation of funds out of revenue, while actual expenses might come in large and not consistent chunks. Your allocation can be smooth and consistent because you've planned ahead for how much you're going to need at which year, which month of which year. So you'll have a smooth allocation while not necessarily a smooth expenditures. And also your fund can be invested, and with the investment return potentially augmenting the deposits, so increasing the amount of money you have in the account. Also, investment can be used to offset inflation. And sometimes you might only retain a partial fund to cover years with higher than average capital replacement costs, and then use revenue to cover the normal or less expensive years. All right, now, depending on your business philosophy with respect to investment and cost of capital, your organization might not want to set aside a large amount of cash just for capital replacement. They instead want to invest in business growth while potentially maybe retaining some earnings for general use, but not necessarily specifically for capital replacement. And in this case, it might be especially important to smooth out the annual replacement costs to make allocation more predictable. Basically, try to keep the capital replacement allocation close to the same maybe percentage of company revenue each year or something like that. And this can be done, like I think I mentioned before, by shifting things forward and backwards a few years, spreading certain expenses over multiple years, or prioritizing. We can push that off till next year or 2 years from now, while maybe we have to do this one a year earlier or this year, and that'll help you smooth out the budget. And sometimes there won't be enough money to cover everything in the capital replacement plan. And in this case, you need to prioritize. And so your highest priority things are going to be things that impact life safety or structural integrity or legal compliance, and probably in that order. So first, you want to replace things that risk hurting someone or destroying the building or getting your business shut down. And again, your facility condition assessment consultant, if you use one, can help you identify these things. Your contractors can also help you identify these things. And the next priority is going to be high return replacements. So some replacements will have a clearly superior financial benefit in terms of efficiency or savings and maintenance or whatever. And doing these things can help free up more money for your next year's budget, put a little more room in the capital replacement plan. And then after that, your next priority will be productivity or morale, the business mission. So these are things that will help your business make more money, which is obviously good for everyone's budget. And then your next priority will be things like aesthetics, company image, historical preservation, advancing the strategic plan of the company, and that sort of thing. Now, when evaluating the priority of a replacement or deciding whether something needs to be replaced this year, you can look at the actual condition of the item. So if an item has reached the end of its useful life but is still in relatively good working order, replacement could conceivably be postponed until next year if funding is tight or if more urgent priorities surface. And then you also can consider the impact of failure before replacement. So if you decide to postpone replacement and it fails, what's the impact of that? So replacement of a mission critical item or one where premature failure would cause harm to people or incur a massive amount of additional expense shouldn't be deferred too long, while replacement of something that's out of the way or something that's just there for convenience or something that has a high level of redundancy might be more safely deferred until the next year. All right, next thing we want to do, we have a plan, we have it funded, is revise and review the plan regularly. So you want to look annually at your plan. Each year you can evaluate the accuracy of your forecasts and your assumptions about, say, useful life and replacement costs. Compare your forecast or your assumptions, your plan, to what actually happened, and then revise the plan accordingly. And you want your budget for next year to be well informed by your actual experience and the past performance of the program rather than by the assumptions you made in the initial plan. And then one more area to consider is the benefit of this type of planning to your facility manager and FM staff. First of all, you'll be taken more seriously at budget time. So without a capital replacement plan, you go into budgeting time with a list of things that you think need to be replaced next year because you think they'll probably break down soon. And they say, yeah, but that stuff is still working, so maybe you can do 3 of them, and then maybe the approval might never come through. If you go in with a capital replacement plan, you already have buy-in on the concept. Management has already seen your long-term budget forecast and justification for that forecast in their language. So in this case, budget time is just a formality to iron out the details. You've given them the information they need to understand where the money is going and why, so they can then manage the cost, which makes them happy, which makes you happy. Another benefit to the FM staff is the morale of the facility staff and contractors. So it's demoralizing to the people who actually physically keep the building together to watch it fall apart around them. And nobody likes doing a bunch of extra work to clean up an emergency, especially when they know the emergency could have been prevented if the equipment had just been replaced 3 years ago when they actually warned you that that thing was falling apart. And also, everyone would rather schedule the replacement work at the most convenient time rather than perform emergency replacement work time after time at whatever time it has to be done. And then finally, it's a step closer to making FM facility management a strategic partner in the business. So in many organizations, the facility manager and the facility management function is viewed as sort of the on-call janitor or mechanic. Facility management is seen as an overhead and a constant source of problems. And so success with this type of planning can help you be seen instead of as a janitor or a mechanic, as a competent manager of valuable company assets. And this can be a stepping stone to moving your FM program into a more strategic role with the company. And that's good for everyone. So that's what I have to say about capital replacement planning. If you have questions about this topic or comments or suggestions for other topics, you can email me at podcast@facilityscience.com. And notes for this topic are available at facilityscience.com/podcast. And this is number 5. And so keep up the good work, and thanks for listening.